I'll give you an input array of some values, Karthik. So the output array should be squared sorted array. So
just do a map and square it, and then run a sort function.
okay. So squaring, so map basically it is O of n, and
Yeah.
sorting is.
No, don't tell me. Ask me. I'm supposed to be answering, right?
Got it. Karthik, what is okay?
Yeah. So
what is
yeah.
the complexity, time complexity of the map function, Karthik, internally?
It's linear. So it's order of n for mapping. Squaring anyway is constant time.
Yes.
Then sorting is n log n. So it's n plus n log n, which is n log n.
Karthik, I'll add one more condition to this input array. The array will always be sorted. In that case, what edge cases could happen?
The input array is sorted, and you want a sorted array of squares.
Yes.
As output. Oh, then just do a map and square it.
But what will be the edge cases? In what cases this logic might fail, Karthik?
So squaring will always work.
Hmm.
If it was square root, it won't work for negative numbers, etc. Or if it is division, you have to worry about divide by 0. But squaring will always work, except for overflow. That is something you have to think about.
Okay. What if
like
this?
If you're using a
like you said, Karthik, this input array, what if it has negative values? Okay, let's say -5, -3. So even this is sorted. In this case, your logic will fail, right? If we just go with map and square.
Oh, right. Yeah, by the way, you gave away the answer. You shouldn't do that. You should say your logic doesn't work in some cases. Can you tell me what it is?
I am just trying to be polite with you. If it was
No, don't be polite.
If it was other side.
No, don't be polite.
Okay.
No, do it as a real interview.
Yeah. That's why I asked what edge cases it could fail, but you said the negative values, the division. Okay.
Yeah, actually, I was also too much in a hurry. Let's do this properly. Yeah, so then I would go back to my, okay, so sorry. You go ahead first.
Yeah, Karthik. So the input array, it can be sorted, but like we discussed, it might have negative values also. But irrespective of the values, it will be sorted. Now, how you will solve this problem?
I would assume okay, so I'll just repeat the problem. I have an input array of numbers. I want an output array of squares of numbers, which is sorted.
Yes.
So I would ignore the fact that the input array is sorted. Okay, so again, there's a quick solution, there's an optimum solution. Quick solution is ignore the fact that the input array is sorted, just square all of them and sort them once again.
Just sort and square.
Okay, so there it would be n log n time complexity. And n space complexity.
Okay. Sorry, Karthik, what will be the space complexity?
N.
Okay. Because we will be returning an output array.
Yes. Now, I mean, if you want, you can change it in place, which will still be n, but it will save memory. Anyway, so now let's come up with a more optimum solution. Which is, first I would square all the values, which is n. And let's assume I'm doing it in place.
Squared all the values. Okay, Karthik.
Right. Now what I would do is I would create a new output array, which is empty.
Okay, Karthik.
And I would maintain two indices, start and end. So I'd iterate through this array, both from the beginning and from the end at the same time.
Both at the beginning. Okay, Karthik.
Just call it begin and end, and initialize begin to 0, initialize end to n minus 1.
Begin, end.
begin equal to 0, end equal to n minus 1.
Okay, Karthik.
Now compare input array of begin and input array of end. If input array of begin greater than input array of end, so you want in ascending order, right?
Yes, ascending order will work.
Oh, okay, cool. So now what you do is you compare these two. If at the end, just write the code. Yeah, if input array of begin greater than input array of end.
Yes. If input array of begin
greater than input array of end. Output dot append. Input array of end.
Input array of end.
And the lower value, right?
Yes.
Minus minus end.
Also, you're decrementing the values also.
No. Next line. First append it, then then decrement. Else output dot push input array of begin.
Output array dot push
Input array of begin. Then next line plus plus begin.
Okay.
And then you stop this loop when begin equal to end. In both cases, right? After the if else, right? You would say if begin equal to end, stop loop. And break, yes.
Okay.
So now the basic idea is that the reason n log n time complexity is required for sorting is that for each value, you have to compare it with many values because you don't know where it is. It could be anywhere, the next value, right? That is why sorting takes n log n. Here, it will either be at the beginning or the end.
Yes.
So basically, this array, the squared array, it is a decreasing array followed by an increasing array. It's not a completely unsorted array.
Yes.
So if you look at the example you have given, 25, then decreases to 9, then decreases to 1, then keeps increasing.
Got it. Nice.
So now, this is a linear algorithm. Now, the only thing I would do is when I initialize the output array in step 2, arrays in some languages have a capacity, which is how much memory it allocates so that it doesn't keep expanding the array multiple times. Otherwise, what it does when you append more memory, then it's a new array, copies all the elements, right, internally. So some languages have a capacity of an array list or a vector or a list, whatever you call it, which is different from the size. It's like pre-allocated memory. So what I would do in step 2 is output array dot ensure capacity n after initializing it. So the size is still 0, but internally it has allocated that much memory. So it doesn't need to do reallocations as you keep appending.
So in JavaScript, we can do it like some array of some length. So basically input array dot length we can do. Got it. This is a good.
No. So again, I don't think this will work because the size is different from the capacity. If you do this, if you say, I want 10 copies of 0, and then you append something, it appends at the 11th position, right?
Correct. If I, yes.
That's not what it does. Yes. Yeah. So the size should still be 0. So what you would do is output array equal to empty. Then you would say output array dot ensure capacity n. So there's a size, there's a capacity. So this is one way of doing it. The simpler way is I would just create output array which has n zeros. So suppose you're using a programming language that does not offer this facility of ensuring capacity.
Okay, Karthik.
Then one way you can do it is just keep appending. A better way of doing it is just create n zeros in the output array. Create a third index, output array index, initialize it to 0. And when instead of doing output dot push, you do output of output array index equal to value and plus output array index.
Got it.
So let's analyze what we have.
Yeah, Karthik.
First, we are squaring. Sorry.
Karthik, I just want to run the code so that we are getting the expected output.
Sure.
Can you do that? Okay. So first of all, we have assigned 2 pointers to indices, begin and end. Now input array dot begin is not greater than end. This is okay. Now Karthik, now if and else condition we are checking 25 and 25, Karthik.
Oh yeah, this doesn't work, no? I think what we need to do is we need to create an array in descending order, then reverse it.
Yes, that also works.
So how about this?
Reversing it is work.
Yes, in this if condition, change the greater than to less than.
Okay, Karthik. So now 25 is
so now what we are doing, we are pushing the bigger value to the output array.
Okay, let me try to do that. So begin is not less than end. So 25 is
no, 1 second. 1 second. There is one more step here. At the very end, you have to reverse the array.
Yeah, got it. Let's not worry about it, Karthik. Maybe the sorted can be descending order also. Okay. Now, as per the code, input array of begin is less than input array of end. So it's not. So begin will get incremented to here. Now we are comparing 9 and 25. 9 is less than 25. So 25 gets, yes, this works. So finally, 25, 25, 16, 9, 4, 1. So we can just reverse it. So since the sorted is the requirement, this works. Okay. Okay, there is only one comparison. Yeah, Karthik, this is a linear solution. Can I say the solution I came up with, Karthik?
Sure.
So my logic for this, when I was interviewed with this question, I just create a negative array and track all the negative values, create a positive array, track all the values, reverse the negative array, square both positive and negative, both square both the arrays, then merge them in the merge sort concept, Karthik, the final step of merge sort. So all these
steps that also works.
All these steps are work.
Yes.
Yeah, Karthik. I thought recently I read in your blog post about one problem statement where you decoupled that array into negative and positive. So I thought that you will also come up with the same solution, but you came up with the classic pointer approach. Pointer approach is so cool, always. The fun thing is I gave this answer. Interviewer was not aware of this solution. Then he said it's a good solution. Can we think about any other solution? He even gave me a hint of pointer approach. But I said no, I won't be able to come up with pointer. Cool.
Let me make this problem harder for myself. We'll see if I can solve it. Let's assume I can't create any temporary arrays. I'm given one array. I can create local variables, but I cannot allocate another array because memory is very limited. And the original array is huge. It contains billions of values.
Yes.
So let me try to solve that problem here. So first step is I would just go through the array, square it in place.
Just a minute, I think no
Yeah.
extra space.
No extra arrays. Local variables are okay.
I'll just use like the constraint is you can't use extra space. You just
Sure.
so the problem statement is you want it to in place, right, Karthik?
Right. I mean, I just mean local variables are okay, but not arrays. Like if you're iterating, you would use a loop variable, right? That is okay.
Yeah, got it.
Should I try to solve it?
Yeah, got it. Please say the steps.
So first step is just iterate through the input array in place and square it and store it back.
Square it and yes. Okay.
So at this point, we don't have to worry about squaring or negative values. Now the second step will be, and this can be combined with the first step also, find the point at which it stops decreasing and starts increasing.
It stops decreasing
and starts increasing.
Okay.
So for example, here it would be 1, which is the index 2. So from 0 to 2, it is decreasing. From 3 onwards, it's increasing, right? Find that point.
Okay, Karthik.
So now what would I do? We need to do it in constant time. Otherwise, it's very easy. You can do an n log n sort of this array and you're done without any additional space. But let's assume that the time complexity should also be n. So basically, we need to come up with an optimized sort algorithm for this case. So now you have a decreasing array followed by an increasing array. One thing we can do is convert both to increasing by swapping the first array. So the first 3 values you would swap. Okay. So in this case, it would be 25, 9, 1 would become 1, 9, 25. Just reverse.
Okay, Karthik.
Right? Now you have 2 sorted subarrays. You have to combine them. Now just use the merge sort algorithm by using 2 pointers. First index, second index. First index would be initialized to 0. Second index would be initialized to the midpoint plus 1. So in this case, it would be index 3, which is a value 4. And then whichever is lower, you take it and you increment that value. Standard merge sort algorithm.
This is a very cool solution, Karthik. So I'll just confirm whether I have documented the steps correctly. So till this point, it is clear. So we just need to find the midpoint where it stops decreasing and starts increasing. And from that initial 0 to that point, reverse it. Then consider it as 2 subarrays, merge sort, and we will have the in sort, in place, sort, and squared array, which is of linear solution.